Welcome to Math 12, the very first page of our Canvas, Chapter 1, 1.1. Let's click on that. Let's download the file. These are PDF files. You can download them. You can also print out these files. Chapter 1, 1.1, Introduction to Functions and Relations. Let us begin by defining a function. A function, denoted by f, from a set like A to a set like B, is a relation that assigns to each element x in set A exactly one element like y in the second set B. So f as a function takes values in set A and map them to set B. It acts like a machine. You plug in some values into function f makes some changes and give you some outputs. The first set, A, is called the domain or set of inputs, input values. And second set, B, is called the range of function f. So we have a function, we have domain and range of the function. We can visualize a function by using some arrows. Take a look at these two sets. The set A, including 1, 2, 3, 4, 5, and 6. A function like f maps the first set, time of day, to the second set, which includes temperature. The second set has a lot of numbers, a lot of values. This function like f takes 1 and map it to 9 temperature. So at 1 p.m. the temperature is 9. Function f takes 2 and it maps it to 13. At 2 p.m. the temperature is 13. Function f takes 4 and it maps it to 15. At 4 p.m. the temperature is 15. Function f takes 3 and also map it to the same output, 15. Your input value is 3, your output value is 15. Function f takes 5 and map it to 12. At 5 p.m. the temperature is 12. And finally, the last value in the domain is 6. Function f takes 6 and maps it to 10. At 6 p.m. the temperature is 10. So we can represent this function using points. The set of the first point has x equals to 1 and y, the output, equals to 9. This function has second point, 2 and 13. 2 is your x value, 13 is your y value. This function has point, 3 and 15. X is 3, y is 15. Next point is 4 and 15. So your x value is 4, your y value is 15. We know that f takes 5 and maps it to 12, so next point in this set is 5 and 12. And finally, the last point in this collection has first coordinate 6 and second coordinate 10. We represent our function this way. Since you have just finite or countable numbers in your domain, it's easier to list all the values, all the members in this function. When we have more points, infinite numbers of points, we prefer to use formulas. Different ways to represent a function. First, you can use a sentence and describe your function. The function takes on some values, some input values, and it gives you some output values. Second method, numerically. You can use a table. You can use a table like this. On the left-hand side, you can write input values, x values. On the right-hand side, you can write output values, y values. For example, take a look at our function here. X is 1, y is 9. The first point. X is 2, y is 13. X is 3, y is 15. We can continue. X is 4, y is 15. X is 5, y is 12, and finally, x is 6, and your y is 10. We can graph our function. So suppose I have these values, and my goal is to graph my function. X, horizontal axis, y, vertical axis. So on x-axis, I have 1 through 6. On y-axis, I have 9, the smallest value, and the largest value is 15. Okay, we'll scale it this way. 3, 6, 9, 12, and 15. And here we have 1, 2, 3, 4, 5, and 6. 1 and 9. The first point on the graph of the function. 2 and 13. The second point. 3 and 15, which is going to be here. 4 and 15. So the same y value. 5 and 12 is going to be here. 6 and 10. Almost here. So we can visualize this graph. Note that we don't connect these points because we only have some points. 1, 2, 3, 4, 5, 6, and this example doesn't give us any continuous function. We only know some points on the graph of the function, and we leave it as it is. And finally, algebraically, we can write equation of a function. And let us move on to the next page. Very well, construct a table and graph for the following function. Here you have y equals to 8.5 times independent variable x. X ranges between 0 and 40. So it can take on any value in between these two numbers. It can be a radical, a fraction, a decimal. So let us form a table. This is the definition of your function. As you can see, it's a linear function. The degree of x is equal to 1, and here you have a linear function. We're going to review linear functions later. Okay, we can take on different values for x, evaluate the function, and have our output values. The smallest value in the domain of the function is 0. So remember that you can write the domain of the function this way. Close bracket, 0, comma, 40. Let us close the bracket. This is the domain of your function. The smallest value is 0, so let us plug in 0. Y is equal to 8.5 times 0. 0 times any number is 0. So the very first point on the graph of the function is 0 and 0, which is the origin. We can form the table and graph the function by plugging values for your x. You can take x to be 5, x to be 10, 11, 12, anything you like. Let us select 10 and plug in 10 to the function. Y is 8.5 times 10, which is 85. So the second point on the graph of the function is 10 and 85. This is your second point. We can plug in 15, 16. Let us plug in 20. Y is 8.5 times 20, which is 170. Next point on the graph of the function is 20 and 170, the third point. Let us plug in 30. Y is 8.5 times 30, which is 255. This is your next point, 30 and 255. The last number in your domain is 40. It means that you cannot plug in 50, 60, 70, 100. You have to stop at 40. So let us plug in 40. Y is 8.5 times 40, which is 340. So x is 40 and y is 340. Okay, we plug in this, we graph this point and the final point. Okay, now you're allowed to connect these points. Why is that? Because we could select x to be 1, x to be 2, x to be 3. X ranges between 0 and 40. That's why we connect all of these points, and this is the graph of this function. Okay, let's talk about domain and range of a function. So the domain of a function is the collection of all input values. The range of the function is the collection of all output values. So a function takes values in the domain, input values, and map them to a collection of output values. So what if we have a function, and we want to find the domain and range of that function. For this linear function, y is equal to 8.5 times x. You're lucky in this case. In this example, the domain is actually given. It says, hey, the input values must be in between 0 and 40 inclusive. So the domain of the function can be any value between 0 and 40. Any number in between is acceptable. So you can either use set notation. We read it this way. Curly brace, you read it as the set of all x values. Since you are working with the domain, the variable that we're using is x, such that x is between 0 and 40. Then you close your curly bracket. You can use interval notation, close bracket 0, close bracket 40. So remember that in general, if you have an open interval, a and b, you can graph it this way. Open circles, since a and b, the end points are not included, we use open circles. If you have half closed, half open interval, on the left-hand side, a is included, so you use a closed circle, a filled circle. On the right-hand side, since b is not included, you can use an open circle. And you shade all numbers in between. Half open, half closed interval. On the left-hand side, a is not included. That's why we use parentheses. So open circle. And on the right-hand side, since b is included, you use a filled or closed circle. And you shade all numbers, all values in between. And finally, a closed interval, including a and b, has a graph like this. Since endpoints are included using bracket, we use filled circles, and we shade all numbers in between. That's why we use closed brackets here. Since 0 and 40, both of them are included here. We can actually see this equality on the left and right-hand side. That's why you use closed brackets. Okay, this is our domain. Set notation, interval notation, and that's how we visualize the domain of the function. How about the range? Let's get back to the table here. X values, the domain, and Y values, the range. For Y values, the range, the smallest value is 0, and the largest value is 340. Range or Y values, starting from 0 and stopping at 340. This is your range. All numbers between 0 and 340. As usual, we can use set notation, the set of all y values. Guys, here we are using variable y because we are working with y-axis, vertical axis, such that y values are between 0 and 340 inclusive. Since we have equality on the left and right hand side, it means that we are working with a closed interval, 0, 340. Very well. We can visualize the range using a vertical line, 0 and 340, and you shade all numbers in between. Let us move on to the next stage. So when you have a function, you can say that that function maps x values, input values, to output values. So 10 is mapped to 85 by your function 8.5 times x. 20 is mapped to 170 through function 8.5 times x. So in general, you can say that, hey, a random variable like x is mapped to 8.5 times x. And we write it this way. F of x is equal to 8.5 times x. This is your function. As we mentioned, this is a linear function. So formally, we say that a function is a rule that pairs each element in one set or the domain with exactly one element from a second set, which we call range. Function f maps x values into y values. Another example. Kendra tosses a softball into the air with an underhand motion. The distance of the ball above her head given by the following function. Okay. H, function h, is equal to 32t minus 16t squared. You can also write this function this way. H of t, function h, depends on variable t equals to 32t minus 16t squared. T, or the domain, ranges between 0 and 2. The degree of this function is 2, so it's not a linear function. It's a quadratic function. Quadratic function. Okay, our goal is to graph this function and understand the behavior of this function. Let's start by using a table. We know that the domain, the set of all input values, start at time t equal to 0 and stop at t equals to 2. We can plug in different values in between 0 and 2, calculate the output values. Okay, perfect. When t is equal to 0, the output value is 32 times t, which is 0, minus 16 times 0 squared. First of all, here you have multiplication and subtraction. Multiplication comes first. So first we multiply 32 by 0, which is 0, minus 16 times 0 squared. Remember that 0 squared is 0 times 0, which is 0. 16 times 0 is again 0. 0 minus 0 is 0. So when t is 0, the distance for your function output value is 0. The very first point on your graph is 0 and 0. Let us select another number, small number between 0 and 2, like a fourth. Plug a fourth in to the function, 32 times t. Now your t is a fourth, minus 16 times a fourth squared. 32 times a fourth is 8, and 16 times a fourth, so a fourth raised to 2, it's 16 times a fourth times a fourth. You multiply the denominators, 4 times 4 is 16. You can cancel out these. The outcome is equal to 1. So 8 minus 1, which is equal to 7. When your t is a fourth, your distance or the output is 7. So the second point on the graph of the function is a fourth and 7. Second point on the graph of the function. Let us plug in another number like a half into the function. 32 times a half minus 16 times a half squared. A half squared is a half times a half, which is a fourth. 16 divided by 4 is 4. So 16 minus 4 is equal to 12. The output value is 12. When t is a half, your y value is 12. A half on the horizontal axis and 12 on vertical axis matched to this point. As you can see, you can continue plug in other numbers into t and calculate the distance or y values. For example, if you plug in 1, your y value is 32 times 1 minus 16 times 1 squared. It's a common mistake. Students write 1 squared to be 2. 1 squared is 1 times 1, which is 1. So here you have 32 minus 16 times 1, which is 16. The output value is 16. So when t is 1, your y value is 16. We can plug in 3 halves. The distance or the y value is 32 times 3 halves minus 16 times 3 halves squared, which is 48, minus 36, it gives you 12. Y value is 12. 3 halves gives you 12. Finally, the last number in the domain is 2. So we plug in 2, 32 times 2 minus 16 times 2 squared, which is 64 minus 64 or 0. Now the distance is equal to 0. When t is 2, your y value is 0, so it lands on the horizontal axis. Since t ranges between 0 and 2, it means that you can plug in any number you like in between these two. You can connect all of these points together and you have a continuous graph. This is the graph of our function. As you can see, it's not a linear function. You have a parabola for your quadratic function. As you can see, the domain of the function is given. Take a look at your example here. It says t must be in between 0 and 2 inclusive. So domain is given. We know that our domain is the set of all t values. Remember that our independent value, our independent variable is t. So the domain is equal to the set of all t values such that t is between 0 and 2 inclusive, and we close the curly brace. As usual, you can use an interval notation, closed interval 0 to 2. What about the range of the function? You can look at the graph of the function. Your t values are between 0 and 2, and your y values starting at 0 and stopping at the highest point, which is 16, all numbers between 0 and 16. So smallest y value is 0 and the largest y value is 16. You can look at your table as well. The smallest value is 0, the largest value is 16. Smallest value is 0, largest value is 16. All numbers in between are included. So we can use set notation or interval notation. The range is the set of all h values such that h is in between 0 and 16. We can take on any values in between 0 and 16 inclusive or closed interval 0, 16. Let us move on to the next page. So we learned that we can define a function using some points. Now I expect you to ask, what if I have a collection of points? A collection of points, or we call it a relation. Is it necessary a function? So a relation is a collection of points. Any relation is a function. Okay, let us take a look at this example. Here you have some x values in year, and you have some y values, prices. 2010, the price is given, another 2010, another price, 2010, the third price, 2009, fourth price, and as you can see, you have some X values, some Y values. The graph is also given here. This is called scatter plot. For those of you who are taking statistics later, scatter plot is a collection of points in XY plane. Very well. Remember the definition of a function. For each X value, you must have exactly one Y value. Take a look at this. In 2009, Y values, take a look at this, are almost close to each other. When it comes to 2007, you have some values, okay, almost close to each other. 2010, very close numbers. Is this a function? (2010) has 3 different values that are not exactly the same. So Y values, here we have 3 different Y values. It must be exactly one specific value for 2010. The same for 2009. You have 2 different Y values for 2009. We're good with 2008. We have exactly one output for 2008. We're good here. Take a look at 2007. 2007 has 2 different Y values. We're good with 2006. You have exactly one unique Y value for 2006. Since we have different values for 2010, this relation is not a function. This is just a relation, a collection of points in XY plane. So any relation is a function? No. For each X value, you must have exactly one Y value. Here, your X values are the same, but Y values are different. It doesn't make sense. Or a test, a technique that we call vertical line test. If you have a random vertical line test, it has more than one intersection with the graph of the function at 2 points. Or here, for any random vertical line, it has more than one intersection with the graph of the function. In this case, you have 3 intersections. We don't count these points. We're interested in the points with the same X value, different Y values. That's why this relation is not a function. So a relation is a rule that pairs each element in one set, the domain, with one or more elements from a second set that they call range. So if you compare this with the definition of a function, in a function we don't have or more. In a function you only have one and exactly one element. Or you can say that a relation is a set of ordered pairs. The set of all first coordinates is called the domain, and the set of all second coordinates is called the range of the relation. So we have relations. Some relations are functions. Not all of them. And finally, one example. Example says, sketch the graph of x equals to y squared. We can use a table, x on the left-hand side, y on the right-hand side. Suppose your x is 0. When x is equal to 0, your y squared is equal to 0. It means that y has only one choice to be 0. Suppose x is 1, so y squared is equal to 1. Here you have two choices for your y. Y can be 1, y can be minus 1. Why is that? If you plug in 1 on the left-hand side, 1 squared is 1 times 1 or 1. If you plug in negative 1 for y, you get negative 1 squared, which is negative 1 times negative 1. Negative times negative is positive, positive 1. So the outcome is equal to 1. When x is 1, you have two different y values. Now suppose x is 4. When x is 4, your y squared is equal to 4. Again, we have two choices for our y. Y can be 2 or minus 2. So when x is 4, we have two options for our y. We can continue this. You can plug in 9 for your x. Y squared is equal to 9. So y can be positive 3. Y can be negative 3. If x is 9, you have two options for your y value. You can plug in 25 for your x. You can plug in 100 for your x. You get two different options for your y values. So x is 0, y is 0. The first point on the graph of the function, on the graph of this relation. It's not a function. X is 1, y is 1. This point. X is 1, y is negative 1. So another point. X is 4, y is 2. X is 4, y is 2. This point here. X is 4, y is minus 2. 4, negative 2. X is 9, y is 3. X is 9, your y is 3. This point also, when x is 9, your y is negative 3. 9 and minus 3. So if you connect these points, your graph is going to be like this. Here you can say that, hey, by using the definition of a function for my x value 1, I have two different y values. So it doesn't satisfy the definition of a function. This is just a relation, not a function. A relation or a collection of points in xy plane. Is it a function? Of course not. You can also say that it doesn't pass vertical line test for any random vertical line, it has more than one intersection with the graph of the function. Vertical line, so consider this vertical line, a random vertical line. It has two intersections with the graph of the function. So vertical line test. With more than one intersection. So it means that it's not a function.